Hello fellow wanderers, I am your Arbiter and welcome to the Wanderer's Expanse. Today, I thought we could try something new and take a journey to some of the most interesting places in our solar system that don't get talked about often enough. Moons. Here's a disclaimer, and off we go. Now, while most moons aren't exactly what you'd call a prime vacation getaway, mostly due to the general lack of atmosphere and freezing cold temperatures, there are some rather interesting moons that scientists think could perhaps harbor life. Take for example, one of the most well-known moons from around Saturn, Titan. Titan's surface is remarkably similar to Earth's, with many of the same geological features. The only difference being, it's really freaking cold, getting down to negative 290 degrees Fahrenheit or negative 179 degrees Celsius, cold enough that ice is essentially the rock of Titan. Instead of sand, much of the surface of Titan is covered in dark hydrocarbon grains, which look a bit like coffee grounds. As you walk along, you might be able to feel and hear the ground rumbling and quaking due to the massive self-surface ocean that acts just like magma here on Earth, shifting and recycling the crust. Walking closer to a body of water, you'll notice that the river and lakes on the moon are made up of liquid natural gases like methane and ethane. Now, you may be thinking that this would make the entire moon smell like, well, gaseous cow byproduct. And while that would be hilarious, it's just a myth, and both these gases are actually odorless. If you were to breathe though, well, you'd suffocate, since the atmosphere is about 95% nitrogen with little else except methane. All of this makes the possible prospect of life here, either in Titan's massive subsurface ocean or on the surface of the moon, all the more intriguing. Some other moons worth stopping by are Enceladus and Europa. Generally speaking, these two are actually pretty similar, with Enceladus orbiting Saturn and Europa orbiting Jupiter. Both of them have relatively smooth surfaces composed of mostly water ice, making them very reflective, with Enceladus being the most reflective object in the solar system. They're both geologically active due to their subsurface oceans as well. However, perhaps the best place to sightsee on both these worlds would have to be their geysers. You see, both Enceladus and Europa exhibit cryovolcanism, which is officially one of my new favorite words. Basically, their volcanoes are driven by liquid water instead of magma. This results in huge plumes shooting higher than Mount Everest here on Earth. In the case of Enceladus, the material ejected is thought to make up Saturn's E-ring. By the way, I'm not a gambling interdimensional entity, but if you ever get offered a bet on whether scientists will name something simple in such a way that it makes it absolutely incomprehensible, you take that bet. Now, moving on from frigid worlds, allow me to introduce you to the not-so-frigid moon of Jupiter, Io. And when I say not-so-frigid, I mean something akin to absolute volcanic hellscape. Io is the most volcanically active place in the entire solar system, owing to the tidal forces acting on it from Jupiter and two other moons, Europa and Ganymede. To explain this, imagine squishing a stress ball. Now you squeezing the ball imparts a small bit of energy into it, which changes its shape and actually causes it to heat up a bit. Now imagine instead of a stress ball, it's an object slightly larger than our moon, weighing 8.93 times 10 to the 22nd kilograms, and instead of your tiny human noodle arm, it's the largest planet in the solar system with a mass of 318 Earths. All this means that the surface of Io is in a constant state of eruption and change, with the surface ranging from smooth volcanic basins to mountains taller than, well, Mount Everest. Which actually sounds like fun to climb or hike. You want to go sometime? In some cases, the eruptive materials escape Io's gravity and actually form a donut-shaped ionized ring around Jupiter called a plasma torus. The atmosphere, on the other hand, is rather on-brand for a volcanic world, being mostly composed of sulfur dioxide and sulfur monoxide, which hilariously would actually start to corrode away your lungs if you so much as thought about breathing it in. So yeah, I don't really know where I got that from, but it's not true. Your lungs wouldn't corrode per se, but they would start filling with fluid and you'd still die anyway. Okay, bye. But you're probably thinking, well, at least it's warm. No. The surface temperature of Io is about negative 202 degrees Fahrenheit, but surprisingly its lava flows can reach up to 3,000 degrees Fahrenheit, hotter than any eruption on Earth. So we could probably find a place where it balances out. And finally, one final shout out to the closest celestial body to Earth, that being our moon, which unfortunately doesn't have a unique mythological name like the rest, but I like to call her Luna. Not only is Luna thought to be the remnants of an impact with another planetoid billions of years ago, she is our primary protection against asteroid impacts, as evidenced by her cratered surface. You know, except that one time she wasn't. But regardless, we have a lot to thank our moon for, including our tides and moderating our planet's axial wobble, allowing for more stable seasons. Plus, in my opinion, she has one of the best vistas in this whole solar system. On a side note, to the wanderers whose first time it is traveling through the void of space, Rest assured, you won't explode or freeze in space. Since there's no matter to transfer the thermal energy to, you'd just be slowly losing heat through thermal radiation alone. Though you would feel the light from the sun with no atmosphere, so you'd get an absolutely terrible sunburn. As for the explodey bit, you wouldn't explode since it's not like the weight of Earth's atmosphere is the only thing holding you together, but the near absolute vacuum would cause the air in your lungs to expand, resulting in them rupturing unless you exhaled. But you see, that's where the fun begins. As soon as you expose your lungs to the near vacuum of space, gas rapidly diffuses from your blood, giving you about 12 to 15 seconds of consciousness before you pass out. So if freezing in space ever kept you up at night, you can now rest easy knowing that you die of suffocation long before that. Sweet dreams now. Anyway, I've been your Arbiter, and thank you for wandering with me today.